In this video, we will be learning about how to graph sine and cosine functions. So today's objective, we're going to look at specifically the variations of sine and cosine, where we have some type of transformation being done to these sinusoidal functions. So before we begin, let's look at how we write a general equation for sine and cosine and what the a, b, and c, and d values represent. So the a value is the amplitude, which sometimes is referred to as the height of the sinusoidal graph. The b value is used to calculate the period, so how far does the graph have to go before it starts to repeat itself? And in order to calculate the period, we use 2 pi divided by b, because sine and cosine take one cycle from 0 to 2 pi, or from 0 to 360, before it starts to repeat itself. The c value is the horizontal shift, and the d value is the vertical shift. So in this first example, we're just going to identify the 4 variations to this sine equation. So we can see that it follows that general format of a times the sine of b x minus c plus d. So this -3 is equivalent to my a value. And remember that a represents the amplitude. So the amplitude in this case is 3. The negative that is out in front just describes that it's going to be reflected over the x-axis, but the amplitude is always going to be a positive value. If you wrote it as a -3, there's nothing wrong with that, but just know that ideally we'd like to see it as a positive value. The period, we're going to look for that b value, and sometimes our b value is not seen, but it's actually written right here. And so our b value in this case is 1. But that doesn't actually tell me what my period is. Remember that we have to use the formula 2 pi divided by b to calculate our period. So we're going to do 2 pi divided by 1, which simplifies to 2 pi. So in this equation, it's going to go from 0 to 2 pi before it actually starts to repeat itself. Our horizontal shift can be found here in our c value. Okay, so right here is our c value. Our c value is pi over 4, but we're going to actually give it a direction. Is it going to go to the left or to the right? And that's where we look at the minus sign in front, and it follows all of our normal transformations. So if it's a minus sign in front, it's actually going to go to the right, pi over 4 units, and if it's a plus sign inside of those parentheses, it's going to go to the left, pi over 4 units. Our vertical shift then happens to be with our d value that's here at the end, and that's going to go up 2 units. If it was a -2, the minus would tell me that it's going to go down 2 units. So let's actually get into the graphing piece. And so how I like to do this best is to first identify all of my components. So as you can see here, phase shift is just another way to describe horizontal and vertical shifting as a combination. So in this example, I don't have any parentheses, so therefore I'm not going to have any horizontal shifting, and there's nothing that's being added or subtracted at the end. So this example would result in no phase shift, no vertical shift, no horizontal shift. My amplitude is the coefficient that's being multiplied by sine, and that one is going to be 3. And my period, well, my b value is 2, so that means my cycle needs to happen twice before I get to 2 pi. So, but in order to calculate my period, I'm going to get 2 pi divided by my b value, which is 2, and therefore I get pi. That means that my cycle is going to go from 0 to pi before it starts to repeat itself. So to set up this graph, we're going to make a t-bar with my amplitude, with the height going from +3 to -3. And then I'm going to go ahead and remember that sine starts at the origin. So I'm going to go ahead and make my first point here at the origin. And I'm going to rise up to 3 and fall down to -3. Rise up to 3, fall down to -3, and come back. So at the end, I went from 0 to 2 pi. you can see that my cycle repeated itself once, and then it repeated itself again the second time as I went from 0 to 2 pi. Well, that pi is right here because that's where my cycle first started to repeat itself, from 0 to pi. And if we wanted to get really fancy, we could label these. That's pi over 2 and 3 pi over 2. So this would be the graph of y equals 3 sine of 2x. So let's go ahead and do another example. Again, the phase shift is the horizontal shifting and the vertical shifting. And in this case, we don't have either one of those. There's nothing that's being added, subtracted at the end, and there's nothing within the parentheses. So again, we have no vertical or horizontal shifting. My amplitude, again, is the coefficient that's leading in the front, so that is 4. And my period, well, that's my b value is 1/2. But that doesn't tell me what my period is. Remember, you have to take 2 pi divided by your b value. So that's going to be 2 pi divided by 1/2. Again, multiply by that reciprocal. So I get my period to be 4 pi. That means that I need one full cycle of my cosine graph to go from 0 all the way to 4 pi. So that b value reminds us that I'm only going to have half of my cosine graph done by the time I get to 2 pi. So let's go ahead and start setting up our t-bar graph just to see how this would look. Again, our amplitude starts at 4 and it will go down to -4. And then I have to remember, where does cosine start? Well, normally cosine would start at the point 0, 1. But with that amplitude, it's going to start at 0, 4. So that's where my first point is going to be, is up here at the point 0, 4. Cosine comes down first, so we'll make that down, and then rises up, and so that is where it's going to end. So right here is my 2 pi, because this is where half of my graph is. It stops right there, right here. So, and it ends at 4 pi. Here's pi if we wanted to get fancy, and here's 3 pi are my x-intercepts. So that would be the graph of y equals 4 cosine of 1/2 x. So let's switch from graphing them ourselves to now writing the equation based off of the graph. So here's how I like to look at it. First off, I like to consider if I'm looking at a sine graph or a cosine graph. And in this case, I'm looking at a sine graph because I see that it starts at the origin. So I'm going to go ahead and write that reminder for me that I'm working with a sine graph. The next thing I need to notice is it being shifted up at all? Is it being shifted down, left or right? And the answer in this case is no, it's not. So we don't have any type of shifting. The amplitude, we can calculate that by first identifying our minimum and our maximum and drawing our middle line. Okay, so our middle is going to be the x-axis here. When you identify that middle line, it also helps you to determine if you have a vertical shift or not. So the amplitude comes from looking at your middle line, the line I drew in blue, and then connecting that to your maximum and to your minimum. Now that distance is your amplitude. So if we look at the maximum going from 0 to 1, that distance is 1. So that means that's my amplitude. Now my period, how do I calculate that? Well, as I look at this graph, I'm calculating when does it start to repeat itself. Well, it repeats itself from -2 pi to 2 pi. That's how long it takes before it repeats itself. So if that's the case, that's a complete distance of 4 pi units. So what I'm going to do is I'm going to calculate my period of 4 pi, but I need to find my b value. And how I do that is taking 2 pi over b, setting that equal to 4 pi, and solving for b. And what you'll end up with is b equaling 1/2. So now I have enough information here to be able to write my equation. So the equation is going to be y equals my amplitude, my trig function, and then my b value, and then x. So that one that I wrote as my amplitude is not necessary, so you could easily write it as y equals sine of 1/2 x as well. Let's take a look at another example. Here is a graph. In this case, we have it starting at the point 0, 1. So that would tell me that we're going to work with a cosine graph. Let's go ahead and identify where our middle is. So I'm going to look for my minimum and my maximum. And it looks like my middle is again going to be the x-axis. So this looks like I have no horizontal shifting or vertical shifting. My amplitude, remember, is that distance that goes from your middle line that I drew in blue to your maximum or to your minimum. Now those distances should be the same. So in this case, my amplitude again is going to be 1. But now I need to calculate my period. Remember, my period is the distance that it takes to repeat itself. So since my graph isn't labeled very well, I need to be able to calculate my period in another way. So one thing that I could do is count how many times my cosine graph goes one cycle between 0 and 2 pi. So we can see that it goes one cycle here, it goes another cycle, so there's 2, and another one 3 times. So between 0 and 2 pi, my graph repeats itself 3 times. So that 3 is my b value. So I can see that my period is 2 pi divided by 3, so it's 2 pi over 3. So you can see why that would be difficult looking at my graph and how it's not very scaled very well. So now that I have my information, I can go ahead and write my graph or my equation again. Y equals amplitude of being 1. Again, you don't need to write that 1. So we're going to go ahead and use a cosine. And then my b value being 3, and then x. So here is a trig function that does have a phase shift of some sort. So the best way to go about this, in my opinion, is again looking at where your minimum is, where your maximum is. So I'm just going to go ahead and highlight all of those points. All right, and finding the middle. So my minimum is at -3 and my maximum is at -1. So the middle is at -2. And remember, that's your vertical shift, is wherever your middle is your vertical shift. So I have a vertical shift of -2. I then can go ahead and calculate my amplitude, because that's the distance from my vertical, from my middle line to my maximum or to my minimum. And again, in this case, the amplitude is 1. And then calculating my period. So which trig function am I going to use? I'm not starting at the origin, which is difficult to see because I have that vertical shift. But the origin with that vertical shift would be right here where that yellow dot is. So I'm actually starting up, which would tell me that maybe this would be best if I had a cosine graph. So using cosine, how long does it take to go from one maximum to another maximum? And that is a total distance of 2 pi. Well, if 2 pi over b equals 2 pi, what's my b value? Because that's the number that I need to take in order to put into my equation. And in this case, if you solve for b, you should get b of 1. So this equation would look like y equals cosine of x minus 2. So here's our last example. And again, go ahead by finding your maximums and minimums, and then locating where your middle is. So my middle is halfway between -3 and 1, and that's going to be at -1. So I'm going to go ahead and draw a horizontal line at -1. So that means my vertical shift is at -1. My amplitude is the distance between my middle line and my maximum, or my middle line and my minimum. So we can see that we have an amplitude of 2. And then again, I'm looking at my period. So where does it, or how long does it take before it starts to repeat itself? So it might be easier seen if we notice that our graph goes through, whoopsies, pressed the wrong button there, sorry. If we notice that our graph goes through this point right here, and we can say that that would be the origin with that vertical shift. And the trig function that is best to use in this case would be sine, because remember that sine goes through the origin. We just happened to take that origin and shifted it down. So we're going to use a sine graph. So how long does it take before this point right here repeats itself? And that's a full 2 pi. So my period is 2 pi, and that would mean that my b value is 1. So we can go ahead and take this information and write the equation. That equation is going to be y equals my amplitude, which is 2, and then we have sine. My b value is 1. We don't have to write that, so I'm going to go ahead and have x, and then my vertical shift, which happens at the end, which is a -1. I hope this video finds some use and is helpful for you to practice or refresh your memory on. If you have any questions, let me know.